Hello students, in this video we will start with the third chapter in science, that is metals and non-metals. Now all objects or materials in the world are made up of elements, compounds and mixtures. And scientists have classified these elements into three types, that is it can be either metals, non-metals or metalloids. Let us first see what are metals. So the example of metals include silver, iron, copper, aluminium, magnesium, etc. Now if I ask you that how does a metal look, or if I ask you to describe a metal, in simple language you will say that metals are hard, metals have luster, they are good conductors of heat and electricity. You can even bend metals into thin wires and thin shades. So all these properties are of metals, and metals have some types of physical and chemical properties. So let us first understand the physical properties of metals. So the first property of metal is physical state. Now physical state means in which state that particular metal is, whether it is in solid state, liquid state or in gaseous state. So all the metals are in solid state only. We have seen that iron, nickel, aluminium are all in solid state. Now one thing you have to remember, that all the metals are in solid state except two, that is mercury and gallium. So mercury and gallium are in liquid state and other all the metals are in solid state. The second physical property of metal is luster. Luster is nothing but the shine. If you will look at the metals shine. Also, if you have any copper vessel at your home, use a lemon and just clean that particular copper vessel, and you will see that the copper vessel has started to shine. The light is being reflected from that metal. This is called as luster. So all the metals have luster in them. The third property of metal is hardness. Now we all know that metals are hard. You cannot just break metal by just throwing it, or using a knife we can't just cut them, because metals are hard in nature and they possess the property of hardness. But there are two metals which are not hard and they can be cut with knife easily. So the name of those metals is sodium and potassium. So except sodium and potassium, all the other metals are hard in nature. Now when you take a metal block and you pull it through a small hole, so that particular metal block can be converted into thin wire. So when you convert a metal block into a thin wire, that is called as the property, that is ductility, that metals can be converted into thin wires. It can be easily seen when you visit to a goldsmith shop. Next property is malleability. Now when you take a metal and hammer it continuously, it gets converted into thin sheet. The simplest example you can do is, you can take a particular iron nail and you keep hammering it continuously. What will happen is, after some time you will see that that iron nail has become flat. This property is called as malleability. That is converting it into a flat sheet, that is called as malleability. Next property is conduction of heat and electricity. Now metals are a very good conductor of heat and electricity. Heat and electricity can easily conduct through metals. The simplest example is that we use iron utensils in the kitchen because it is easier to transfer heat in metals. Also, if you will open an electrical wire, you will find that inside those wires there are small minute metal wires which are there, which help to conduct the electricity. So all the metals are a very good conductors of heat and electricity. Now except lead, all the other metals are good conductors of electricity and heat. So lead is not a good conductor of electricity, and lead is also not a good conductor of heat. Next is density. Now density is the mass per volume, and the metals have high densities. That is, all the metals have high density except for sodium, potassium and lithium. All the other metals have high densities. Next property is melting point and boiling point of metals. Now melting point and boiling point of metals has to be very high, because you can't just easily melt iron or copper or other metals. So to melt any metal, we have to use a very high temperature. So that is why the melting and the boiling point of metal is very high. But there are few exceptions. So there are exceptions like mercury, gallium, sodium and potassium. These four have low melting and boiling point, and except all these four, all the other metals have high melting and boiling point. Next property is sonority. Now this we usually hear every day at our homes. कभी भी दो metals को एक दूसरे के साथ बजा के देखो, you will find that you can hear a particular sound. So that is called as sonority. Now why this happens is because metals are sonorous. They produce a sound when they are struck at each other. So when all the metals, when they are struck at each other, they will produce a sound that is called as sonority. Next are the chemical properties of metals. First chemical property of metal is electronic configuration. Now electronic configuration we write according to the atomic number. Each metal has its own electronic configuration and it has its own atomic number. So according to the atomic number we write the electronic configuration. Now there are four shells when we are writing the electronic configuration. First may 2 number of electrons can be there. Second shell 8 number of electrons can be there. In third shell 18 and in fourth shell 32 number of electrons can be there. But now as the number is 11, as the atomic number is 11 for sodium, so electronic configuration in the first shell we will put 2 electrons, in the second shell we will put 8 electrons, and as 8 plus 2 is 10, only 1 electron is remaining, so that will go into the third shell. Same way we write the electronic configuration for magnesium, that is 12. So in the first shell we will write 2, in the second shell we will write 8, and as 2 plus 8 is 10, only 2 number of electrons are left, so 2 number of electrons are then kept in the last shell, that is the third shell. We have fourth shell also, but now as only 12 number of electrons are there, so only this many shells can be occupied. So we have to see that what is the last shell, how many electrons are there in the last shell, that we have to see. So for electronic configuration of metals, all the metals have up to 3 electrons in the last shell. So if they have up to 3 electrons in the last shell, they are metals. So this is the main property of metals, that is electronic configuration. And in the outermost shell, the electrons, there are 3 number of electrons. It can be 1, it can be 2 and it can be 3 also. But it will be only up till 3 and not more than 3. So if it so for all the metals, the electronic configuration is always up to 3 in the last outermost shell. Next is formation of ions. Now metals have the property to lose electrons, that is they will lose electron and they will become positive and become a cation. For example, we will take for sodium. The electronic configuration for sodium is 2, 8, 1. Now here if you will see in the last shell it is only 1. So this shell is not complete. So that is why what it will do, it will lose this 1 electron and it will become stable. So it is losing 1 electron here, 1 electron has lost. अब ये जो 1 electron है वो किसी और के साथ bind हो जाएगा. And now this particular sodium has become stable and it has become a cation and it has now 2, 8 as the electronic configuration. Next is magnesium. The electronic configuration for magnesium is 2, 8, 2. So what it will do, as last shell is incomplete, there should be 18 electrons, but here there are only 2 electrons. So what it will do is it will lose this 2 electron and it will become stable, it will become a cation. So it will become Mg, it is losing 2 electrons, that is the reason we have put 2 plus here, 2 electrons are lost and this has become stable. Next we will take of our aluminium. The electronic configuration for aluminium is 2, 8, 3. Now 3 is incomplete, the third shell is incomplete, it should be 18. So what it will do, it will lose this 3 electrons and it will become stable and it will become a positive electron. So here it loses 3 electrons, that is why we have put 3 plus signs. 3 electrons are lost, these 3 electrons will combine with some other element there and this becomes stable, that is 2, 8 and becomes a cation. So this is how it happens with most of the metals, that most of the metals they lose their electrons if they are unstable and become stable. The third chemical property is reaction with oxygen. What will happen if a metal reacts with oxygen? So whenever a metal reacts with oxygen, it forms metal oxides. And when you treat a metal oxide with acid, you will get salt. So this is what happens when a metal reacts with oxygen. That is, metal oxides are formed. And when you treat this metal oxides with acid, you will get salt and water. Another property of metal is reaction with acid. That is what will happen when metals react with acid. So when metals are treated with acid, it gives salt and hydrogen gas is released. Let's study this with this experiment. So here we have taken a stand and we have attached a test tube to the stand. Inside the test tube, we have taken dilute sulfuric acid. Now this is dilute acid and not the concentrated one. With the dilute sulfuric acid, we have also taken some zinc particles. Now, as we have to treat it with metal, so we have taken zinc. And we have used a rubber stopper here. With this stopper, we have a tube here. And the tube is immersed in this soap solution. After some time, what we will see is that few gases are produced. That is, the hydrogen gas is produced. And that hydrogen gas then travels from this tube into the soap solution and forms bubbles. Inside these bubbles are the hydrogen gas. Now how to test it? We will use a candle here. So when you light a candle to that particular bubble, soap bubble, what you will find is that you will hear a popping sound. So this shows that it has hydrogen gas in it. So from this we can know that when metals are treated with acids, they produce hydrogen gas. Another chemical property is reaction with water. What will happen if you treat metal with water? Well, most of the metals do not react with water. You cannot see any changes in that metal if you will immerse it in water for a very long time. But there are few metals, for example sodium and potassium, which show some changes. So when those metals like sodium and potassium are treated with water, it gives metal hydroxide and hydrogen gas is released.